Does anyone have any questions? Any questions on that? Okay. Here's an example. Go ahead and write this down. Let me erase this question here. We don't need that. Okay, let me know when you're done writing it down. Okay, is everybody done writing it down? Okay, so the total number of members is 100, and so in order to find the probability that a member plays at least one of the three, we're going to label a couple of events here. So let's say event T means that a member plays tennis. Event S is the event that a member plays squash, and event B means that a member plays badminton. How many of you know what badminton is? Okay, many of you know. Have you guys ever played that? Okay. Okay, so then what's the probability that a member plays tennis? Well, the probability that a member plays tennis is the same as the number of members who play tennis divided by the total number of members. Okay, so which would be 36 over 100. What's the probability of S? Well, that's the number of people who play squash divided by the total number of members, so which would be 28 over 100. And lastly, the probability of B, that is the probability that a member plays badminton, is the number of members who play badminton divided by the total number of members. Okay? And notice also that the probability in the question, it is given that the number of members who play both tennis and squash is 22. The number of people who play both squash and badminton is 9. And the number of members who play both tennis and badminton is 12. So from that we come up with the probability of T and S, probability of S and B, and the probability of B and T. And lastly, the probability that a member plays all three of the sports is 4 out of 100, because there are 4 members who play all three of the games. Is everybody okay with that? Any questions on that? So now, what's the probability? What's the probability that, so we are asked, what's the probability that a member plays at least one of the 3 games, right? And so that's basically asking the probability that a member either plays tennis or plays squash or plays badminton, right? So that's basically the probability of the union of T, B, and S. Is that making sense? The question really is, what's the probability of T union S union B? Well, that's the same as, by using the inclusion-exclusion principle, we know that it is the probability of T plus the probability of S plus the probability of B minus the probability of T intersect S minus P of S intersect B minus P of B intersect T plus P of T intersect S intersect B. And then you just plug in the numbers, and then you simply do the arithmetic there, okay? So what do you get? What do we get? I'm sorry? Is everyone getting the same thing? Okay.